Thanks for coming to my session. This session is going to be about Java to Kubernetes for Dummies. If someone is laughing, it means that there is some French people, but so there is no French people, no worries. My name is Santan. I work for, I'm from Paris, if you can tell with my accent. I'm a software engineer working at Red Hat. And I work on a project called Eclipse JCube. And we're going to, I have demo with JCube, so we're going to showcase that a bit later. And during my free time, I'm also co-organizing the Java user group in Paris. And I'm also brewing my own beer in my kitchen. You can follow me on Twitter with the hashtag @__Unix_, so double underscore. And I'm also in Mastodon. I put just below some hashtag. If we have time, I would run a raffle at the end to win an IntelliJ license. So you have to just take pictures and tweet with this hashtag below, and yeah, if we have time, we do that, and we do that with JCube. Okay, so let's go back in time. It was like 8 years ago. I was working for a company and we were doing a train ticket booking system. And this application was running on Java, Java 6 with Struts 2. I don't know if people have ever used Struts 2. And it was running on Tomcat, and the machine was running on a virtual machine with CentOS. And this is how the production environment looked like at the time. We had a reverse proxy load balancer that was load balancing the traffic into two Tomcat. And then we also the data were persisted into a MySQL database that was also replicated. So that was the production environment. And we had also a pre-production environment that looks like the same, but because it costs money to run a VM, it has just one Tomcat VM and one MySQL database. And so everything was running on CentOS. For the developers, we had in our open space in the office. So we all were running our development environment on the laptop on Windows 7, and we had installed Tomcat in there, and we were all connecting to a MySQL database that someone has installed in the open space in the office in one machine. I don't know if some people had ever had this kind of experience. No. Okay, that was a bad experience for me. And of course, this application was customized for several customers. So it was a big mess. So we had the main problem the main pain point of that kind of infrastructure. It was for the deployment and the update. The upgrade of the application. What we had to do at this time, it was 8 years ago, we were pushing, so we were building the application, so a WAR file or a jar file. It was a WAR file, it was on Tomcat. We were pushing that to, so building and pushing that to an FTP server. And then the hosting provider had an issue tracker when we could ask for to someone to make the upgrade of the application. So can you hear me? Is it better now? Okay. And we had to deploy the application by creating a ticket in the issue tracker, and someone was taking it and manually installing the application in the environment. And it was working most of the time, but sometimes it was a bit difficult because, for instance, sometimes we had to upgrade the version of the JDK, and sometimes we had to change the database schema. So there was a lot of manual steps, and sometimes the person working at the hosting provider were making mistakes. Who knows Naruto? Yeah, good. So Naruto, he has a technique to clone himself. But at the beginning, it wasn't that perfect. You know, his clone was sometimes too big or too small. It was not perfect, and it was exactly the same thing when we in the company I was working for. When we wanted to scale, so add one more Tomcat, what the person was doing he was actually creating a VM based on the same operating system, so CentOS, and then he was installing manually all so Java, Tomcat, and on the application as well. He was installing it manually. And of course, sometimes he made some mistakes, and it was also hard to maintain. So it was not perfect. That's the second pain point. The third pain point, I don't know if anybody has ever debugged in production. Who? You know that it is not good to debug in production. It's evil. But I can understand because, for instance, in my case, our developer environment, our laptop was running on Windows 7, and in production it was CentOS. And sometimes it was hard to reproduce the bugs. So I can understand that some people say, oh, I cannot reproduce the bug, but maybe I can reproduce in production. Okay? So here, our savior, Kubernetes. So Kubernetes is infrastructure as code, and it should solve most of your problems. For instance, for your developer environment, you can duplicate your environment and have exactly the same environments that is a clone of the production environment, but just for you. And you can instantiate a complete infrastructure. And then when you finish with that, you can throw it away. That's not a problem. And same for scaling, it's just about changing a number in the YAML file. And what else? And for deploying, it's just about packaging it through YAML files and Docker files. So it should save a lot of life. But to be honest, the first time I heard about Kubernetes, it was in a conference in France, Google Dev Fest Paris, and I didn't understand anything. I think it's you came here because you need more explanation. There is this book was a nice title. I didn't read the book, but I love the title. It says think big, start small, and scale fast. And I think when it is about learning, you can also apply this sentence: think big, start small, learn fast. What is interesting in this sentence? It's the start small. And if you want to start with Kubernetes, I think what you could do is start maybe with the containers. Why containers? Because containers are used in Kubernetes, and because also you can use containers without Kubernetes. So it's a good way to start to start with Kubernetes, with the containers. So what is a container? It's actually taking the best of the both worlds, which are the traditional approach to deploy an application, which is running your your app in a machine in the operating system, and the virtual machine, virtual environment, where we emulate an operating system and provide a set of library that works with your software. The problem with the virtual environment is that, so it's good because you can really customize and have images that really suits your to your application, but it is not as performant as the traditional approach. And containers take the best of the both worlds. Means that you're actually going to run your application in the host operating system, but the application will think it is running it's in our own virtual machine. It is not true, but for the container, he cannot see other applications. For instance, he has his own file system, and yeah, so he's buying his own, but he's actually running inside a real machine. If you want to use the containers, there is two choices for me in your laptop: Docker or Podman. So Docker is of course the most popular one. Podman is an alternative made by Red Hat. Normally, you should find the same feature in both of them. The advantages with Podman is that it is daemonless. You don't have to be root to have root access to your machine to run Podman, and it is free of charge. Okay, so if you want to start a container, start with container, the first thing I would do is to run an existing container. Okay, so there is what we call registry. What there is, you can find a lot of containers that has been published by the community. So for instance, if I go there, so this is the Docker Hub. It's a registry where you have a lot of containers. So I can browse, and you can see there's so many images. And if you want to try one of the images and run it on your computer, you just need Docker, of course, or Podman, and and run this command: Docker run -p. So this is for port redirection, and then the name of the image, and then at that point you should be able to access your application. So I have a demo for you. So it's of course a fake live demo, and so containers and run. Okay, so I'm running Podman because I like it, and I will run this exactly the command that I showed to you just before in the slide. In Podman, it will ask in which registry you want to pick the image if you don't specify it. Okay, and then it downloads the image and run it on your computer. So I'm going to use a web browser, a command line terminal-based web browser, and access to the container Apache server. Okay, if I stop the container, Ctrl+C, you see it's not running anymore. It's failing to access to my container. Second thing you want to do, then you have run your existing container, it's to access, to execute some commands inside the container. And you could do that, but the first thing you have to do is to run a Docker PS to get the list of the containers. And then you can use Docker exec, the idea of the container, and the command you want to run. It would run the command inside the container. You can even have a terminal, an interactive terminal with the option -it. And you have to specify a shell like sh or bash. And then what the thing is that is interesting to do is to access to the file system. You would see that it is a completely different file system that's the one that you have in your machine. And the processes, it is only the one that are in the container. So I'm going to run the demo. So there is one container that is running. I do Podman PS, just PS. So then I get the idea here. I can do Podman exec, the container ID, and the command I want to run inside. So pwd is to get the current folder, yeah, and then PS to get the process that are in the container. If I'm going, so now I'm showing how I can access to the container with a terminal. So with the option -it, and I have a terminal, I'm inside the container. You see I can browse with the terminal. It's a different file system. And if I compare with the host machine, you see that the host machine have a lot of processes. I don't have just HTTPD. But in my host machine, I also have the processes that are running inside the container. So the processes that are running in the container are actually running in my host machine. That's the most important thing you have to understand. So it's really like you are in this situation, but it is actually running there. And you don't know, you can only access to the file system, and you don't see the other process of the other machine. Next thing, what you want to do is to create your own image. So there is a file format that we call Dockerfile to create your own image. And this is the very simple one that you can use from an existing image. And then you can copy a file that you have already built inside the container. And this is how you can execute build with. So you have to of course build your WAR file and then run a Docker build -f the location of the Docker file. If you don't specify it, it would take the one that is in the current folder. And -t is to give a name. You can see that in the name there is, I can specify the registry if I want to push it later on in a registry. Okay. So let's, since this one, create a container. So let's, so I have this file already, my Docker file. It is good because I don't have to type. I can drink some water while he's typing. So I build my project. It generates the WAR file. So we're just checking the WAR file. So it's there. Hello, Tomcat. .war. And then I can use the command build to say, use this recipe to build my image. And this is the name of my image. Okay. And it's going to download the base image. So that was in the form section. And then adding the WAR file in that folder. And it's done. I'm happy. So next step, once you have built what you could do is push that to a registry. And once you push that in the registry, it means that everybody could give a try. So you could even give a try if you have Docker installed. If you run this command, it will download the image that is in a registry. But if you can skip this part if you just run if you have built your image locally in your machine, because you already have that. It's like a local repo like that. Quickly, so I don't remember the names. It's push. So I'm gonna do that. So I have to log into Quay, so which is the registry I want to push my image. I'm already logged in, so that's fine. And then push, Podman push. You can see that it knows where to push because my image name is prefixed with Quay.io. And then it's pushing. And at this time, you can try because I did that a few days ago. it's in the cloud. It's in the registry. And you can, if you can do it in your computer, Podman run. So I have to specify the port to be able to access to the container from my local machine. Come on, can you write faster, please? Okay, so it's running. So it's running, and I can give a try, and it should work. Okay, yeah, and it's asking for cookie. I can say yes, and it works. My function works. So it's a basic HTML file. Okay, so you see this. This is how the container works. So taking the best of the two worlds, as I told you. But a lot of people think that this is why Docker was so successful. But to me, it is not really, I don't think it is true. Because actually container was there for a while, even before Docker. But what is making the difference, why Docker was so successful is because of that. We take a Dockerfile, the source files where we have the recipe to build the image. Then we have the command to build the image. It generates a binary. And then we can push it to a registry. And then anywhere you have Docker, you can run it. You can run these images. And there's another slide. It's slightly different, but quite the same. Up! This is how we are deploying a Java application. So we start from the Java file. Then we use Maven or Gradle to build the project. And then we can push it to a Maven repo, like Nexus or anything else. And then you can run it anywhere you have a JVM. And if you have a look with the previous slide, you see it's quite the same. And to me, this is why it's so successful. Docker is so successful because of that. And the developers, they like it because they can reuse all the developer best practice. And this is, to me, why it's so successful. So we put the source code in Git, and then we use our traditional CI/CD tools to build the project, etc., etc. So you see, yeah. So to me, it's really that. So now, why Kubernetes? So if we have more and more containers in one machine, at some point, if you want to scale, for instance, you would run out of resources. So what you would do? You will open a new machine, spawn a new machine, and put your containers in a new machine. But in Docker, or the container technologies, there's nothing that says how to deal with that. So you would have to do it manually, and also to, for the communication part, how a container can talk to another container. It is not defined in the container technologies like Docker. So this is why Kubernetes come in the game. So basically, Kubernetes, it is magic. So you have a YAML files, a lot of YAML files, that describe your infrastructure. For instance, in the YAML file, you can say, I have a load balancer there that talks to 2 Tomcat, and that will save the data into 2 MySQL database. So you have all that are described in a YAML file, and you can use a command, kubectl apply-f the YAML file, that will talk to a Kubernetes cluster. And in that Kubernetes cluster, for instance, there is a free machine. And what it would do is say, oh, I want to deploy the container for Tomcat. I look at the first node. Oh, there is some space. I will start the container there. And then the MySQL database. I don't have any more space or more resources in that machine. I will spawn it into another node. Machine node is the same thing. And it will do that automatically. It's magic. At least for us. I'm not talking about behind the scene. There are people who are managing the cluster. But for us developer, it's magic. And this is why I love Kubernetes. If you need to give a try with Kubernetes, here I'm listing some tools. Minikube is what I'm using on my machine because I'm running on Linux. I think it's the most easier one to use. If you're running on Mac or Windows, you could use Docker Desktop or Podman Desktop. If you want to try something in the cloud, at Red Hat we have our own distribution of Kubernetes, which is called OpenShift. It's Kubernetes that is easier to install and with a lot of tools around it. And it is maintained and maintained and supported by Red Hat. You can give a try with what we call the Red Hat Developer Sandbox. It's free of charge. Of course, it's limited in resources, but you can make your experimentation there. And I'm going to use that in my demo at the end. And of course, the tool that you need to have is kubectl to talk to Kubernetes, your Kubernetes cluster. There is also OC, which is the equivalent for OpenShift. It's basically the same thing. So you have heard about Kubernetes, maybe. But for me, I have a definition of Kubernetes. For me, Kubernetes is a distributed and structured YAML database. Who has ever read the definition of Kubernetes? No? You don't trust me, right? But it's true. In Kubernetes, you can create objects that we call resources that are structured. All these objects have a type. They are structured with a schema, and you can create. You can read make some search. You can update this object, and you can delete this object, like in a NoSQL database. And you would put all these objects into all these resources, into what we call namespace. Namespace is like a bucket you can group your object, and you can make some permission rules. Okay. So this is an example of a custom resource that I have created. So this object, it has the type here. So the type is defined by the version and the keyword kind. It's a type of my object that will store in my distributed YAML database. And in the metadata part, I will find the name. The name is like an ID in a database. Okay, so it means that I can only have in my namespace a hello resource object with the name hello world 2023. And in the spec, this is where I will find the content. Okay. In my example, in my schema, I have hello, which is a field of type string. And then if I apply that, and if the object is register, I can do a kubectl apply -f hello world, and it will create the object. If I change some the spec, I do a kubectl apply -f again, it will update the object because it would see that it is the same file. And if I change something there, it will update. And I have kubectl get hello resource. It's to get all the resources. I have a demo, of course. Again, kube test, and it was a distributed, a live demo, a fake live demo. So this is the where I define my type. So I define the name of my type. So I can have short names for that. And then in there I define the schema of my. So I say that in the spec section, I can have a hello field that is of type string. And if I try to get this object in my database, it says, oh, I don't know this type. If I apply the definition in my cluster, it says, oh, I know this type, but I don't have any object resource of this type. Okay. So now I have registered my type. I can create my object. So in this file, I have two objects. So hello world with in the field hello have world, and in another object hello jug 2023 with the field Atlanta jug 2023. And I can create this object with kubectl apply -f, and it will create the object. Okay. See, it's so I can list the object that has been created, and then I can have a look to the object in YAML. You can see that it is the same actually object, but Kubernetes has added some metadata. Okay, exit. Control X. No, I don't want to save. So now, what if I change the field? What is in the field instead of hello? I give a field that is not defined in my schema. So if I do that, and it would try to update the object hello jug 2023, but it would fail because it doesn't know the field. A node field, blah, 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 blah. Okay? So it's now you trust me or not? It's a distributed YAML database. But in Kubernetes, there's not only resources, so these objects. There's also what we call controllers. Controllers are like processes. They will listen to the creation, the updates or deletion events of any resources, and they will do something. Depends on the implementation. I can create my own controller and listen to, and then when I get an object that is created, I can do whatever I want. It's up to me. But so this is how it works. There is so the user creates the object, what I call the custom resource, and then in the spec I have what we call the desired state, Then the controller will get the notification. It will do whatever it wants. It can be in the cluster or even outside, or it could be anything. Depends on the implementation. And what usually it does, we haven't seen that, but there is a status field in the object that is populated by the controller to say how it went. For instance, if he couldn't do his job, he can just say, oh, it didn't work in the status field. Okay, and by default in Kubernetes, you have built-in controllers and built-in resources to manage a cluster of machines. Let's have a look to a few of them. The one that you have to know is Pod. Pod basically is to run a container, and so you can see with API version and kind pod, it will create a pod resource. In metadata, we have the name. The name it's kind of an ID in a database, and then in the controller. If I don't have my controller and I create that, this object, it won't do anything. It will just start. But in Kubernetes, there is a controller who is listening to the change of this kind of file. And if you create this object in the database, it will create the implementation of the controller will create the container. It will choose the right node and it will create a container somewhere. Okay. Okay. Kubernetes pod. I have to go very fast because I'm a bit late, but my friend is not typing that fast, so I have to wait for him. Okay, so I have the same file, and here it is. Yeah, so I give the image of the that I want to deploy. So it's the image I previously built and deployed in the registry. And if I do that, so first I will look at if I have any pods in my cluster. I don't have any pods, but if I use the apply command, it will create the pod, the container. It would run the container. Okay. What if I want to scale? What I could do, for instance, is to copy the file into another one. The problem is that if I keep exactly the same content, so if I keep the same content, I do apply of the file, it won't do anything because I have not changed the name. It's the ID. So he would think that I want to update the object that is already there. If I change the name, say, oh, there is no pods with my pod -2, I will create a new one. So this is a simple way to scale, but of course it is not ideal. Okay. So this is why we have another type of resource called deployment. So I would run the demo straight away because I'm running out of time. So deployment service. So in this object, I have a service. I would talk about the service a bit later. But I have a deployment, and in the deployment, there is first a field called template, where you can find exactly the same thing that you had in the pod. It's the same, but it's in a template field. And if you go up, please, my friend. Yeah, go up again. There is a field called replica. Go up. Ah. Okay. So there is a field called replica. Okay, and the value is 1. Yeah. Let's run it. We'll show the replica a bit after. So it's creating the deployment, and if I do get pods, it created 2 pods because in the deployment, I have a field called replica, which the number 2, and this is how we scale. We just have to change the number. And it will create for you, so the controller will look at the modification, and it will create the pods with the same number and using the template. So now I've changed. I put 5 replica, and it's if I try to get the pods, I have 5 replicas. Okay. Okay. The service is like a load balancer, and it's also a way to so other pods can access to a group of pods. So usually, you see here there is I say that if any pods trying to access in my cluster to the service Hello Tomcat service, it will then use this thing called selector and know which pods it has to redirect the traffic. So it's very useful, but it's only inside the cluster. If you want to make your application available from outside, you have to use what we call an ingress. So in ingress, we say what is the host, and you also say which service it should target. So if I then in my web browser type this address, it will redirect my request into the service, which will pick a random pod and get the response. Okay. Chris. I'm good. Okay. Anybody is playing the game in Twitter or not? You don't want an IntelliJ license? Okay, ingress, sorry. So in Minikube, I have to install the ingress add-on, so it works. So I have an ingress. And what I would do is apply this. So it's redirecting to the service, Hello Tomcat service. So the service is already running. In the previous demo, I had defined a service to redirect all the traffic to the pods that has been loaded by the deployment. So I get ingress. I don't have any ingress. I do kubectl apply ingress YAML. It works. It has been created. I can have a look now. And it's so if I access to that link, I should access to my application. Okay. And it works. Say yes. Okay, I have my application running. Yeah. Cool. There's a lot of commands. If there is one you have with kubectl to use, it's kubectl apply. I'm mostly using only this command. Okay. So you remember when we at the beginning, this was my infrastructure was like that, and now I have that. I was in a conference. I showed this slide, and everybody was applause. Yeah. But I said, you don't understand. It's too complex. Come on, you have to take the Java file, use Maven to create your application, and then you have a Dockerfile to build, and then you generate an image, and then you have your Kubernetes YAML, and then use kubectl apply, and then it deploys in your application. It's too complex. I have a tool for you to solve the problem, at least for Java project. It's called JCube. I'm working for JCube. So that's I'm a contributor of JCube. I'm paid by Red Hat to contribute to this open source project. And what it is doing, it is actually, so it's actually a plugin for Maven or Gradle, or plugins for Maven or Gradle. And it provides you some commands to build your image, generate the Kubernetes resources, and apply that to a cluster. And what it will do is analyze your project, see if it is using this framework, Quarkus, or Micronaut, or whatever, and it would detect the type, yes, the framework you're using. It will also look at the dependencies, and with all this information, it would generate for you an image and the Kubernetes resources for your application. And so it would generate something by default. If you're not happy, you can always customize a bit. So to use it, so this is the next JCube website I'm currently refactoring. So here there is the different options: Maven plus Kubernetes, Maven plus OpenShift, Gradle, and Gradle OpenShift. And so what you have to do is to add the plugin in your POM or Gradle file, and then you can run the commands to build the images. This is to push to a registry, and then generate the resources, and then apply to the Kubernetes cluster that you're connected to. Same for OpenShift. It's quite the same. In OpenShift, you don't have to push to a registry because it is doing the build in the cluster. So, but yeah, and same for Gradle. Okay. Okay, so this is an example how you could customize. So by default, it will not create any ingress for your application, and also it will have only one pod that would be deployed. So in the deployment resources, you will have only one. So you could. This is one way. There's a lot of ways to customize that. But you could use so Maven clean install, and then the commands, and then run your application. I have a demo. Actually, I have JCube. Or sorry. So kubectl get pods. So this was the previous pod I created. Then I can edit my POM XML. I have added the plugin. So I have to pick the right one, of course. And then if I just add the plugin and I run the commands, package, and the command to build the image. In my case, I'm using Minikube, so it will deploy locally, so I don't have to push to a registry. It would work, but usually you have to push in the registry. Okay, and then K8s apply, and it will generate the image for you. It will and the resources. You can have a look to. Then to the pod that has been deployed. It has deployed my application. Hello, Tomcat. And then you can upload. Come on. I know it's recorded, but it's super cool. I have a live demo after. Okay, so this is what has been generated. You see. And this file, you don't have to maintain that. The only thing you have to maintain is if you are customizing some configurations. For instance, if here I want to to change, to create an ingress, I can use this property file, this property, and for the replica, I can use JCube.replicas to change the replica that are going to be generated in the deployment object. Okay, come on. Now, I don't have to run the build and package command because I've already done that. So I just do resources. The only thing I have to do is, because I'm on Minikube, it's not a real cluster, I have to specify the host of the ingress. So do it like that. And if I run it again, it generates the resources and then applying to my local cluster. Okay, so if I look at what has been generating, you see, it's 5. And you go down, there is an ingress that is completely configured. Great. I can have a look. I try to maybe access to my application. So get pods. Well, yeah, there's 5 pods. Nice. And I can get the ingress. The ingress in there, I can access to my application. So it should be the same one that we paid before, and it's yeah, it works. Yeah, cool. Okay, so finally we switch from where it is that to that, and it's, yeah, it is a lot easier to maintain and everything. Okay. Yeah, so the goal is to have the minimal file to maintain. If you want to customize it, you can provide a new configuration. Yeah, so and it's also, the goal is also to use your own the existing tools like Maven, if you're already using Maven, to build the containers. And yeah, so you could even not have Docker installed in your machine. There's some option to use something called JCube to build your image without Docker. And it works. Okay, so let's come back to, it's a time for my live demo. And so my live demo, so I will show you an application that I'm running on the Red Hat Developer Sandbox, which is an OpenShift. So that's it's free of charge. It's not working. I have a, what's happening? My database. Strange. Okay. So this is an application, and why it is not working? Do that. Strange. No, it's not a problem. It's not a problem. Okay. So go back to this. So here it's a microservices application. There is this, the front end of the Quarkus application looks like that. It's orders. And normally there is, I have a component here called the order faker. It's a fake Spring Boot application that would generate fake orders just for the demo. But normally it could be people who are filling some orders and sending that to the request to my Quarkus app. And normally it should be refreshing, but it is not. I don't know what went wrong. No problem. And when I click here in send an email, what it would do is send an event to the RabbitMQ broker, and there is a Micronaut application that will listen to this event and send an email wait this to mailinator. So you see just now when I clicked, it sent an email. Okay, so that's good. So that's working. So what if I want to deploy that with JCube? So use that. I want to deploy that. Yeah. Let's make a change. Okay. Let's make a change. Okay. Let's make a change. There, you see, instead of doing to uppercase, we'll just remove that. And I will redeploy that with the JCube commands. So mvn package. So this is OpenShift, so I can use the prefix OpenShift, OC for OpenShift, build OC resources, and OC apply. So it would take a while, a long time, because it's, but it would work, it would update my changes. Okay. So it would take, but this is a problem. So it is very good. So Kubernetes is very good because you can deploy your own instance for testing, and it should be very close to your production environment, right? But then, what if I want to give a try and test a change? I don't want to rebuild everything and push everything each time and make a change. You see here, it takes a while to do that. It will work, but it takes a while. So basically, when you want to work on this kind of application, you want to be able to reproduce and have all the microservices available for your development, maybe. You could do that maybe with Docker Compose, but it's running locally. Same with Quarkus dev services or test container. Everything is running locally, and it may be not that good because you may be limited in your laptop is maybe not that that good, and you may have sensible data that you don't want to bring into your laptop. You could do what I'm doing with deploying with JCube, or you could, for instance, mock everything. But all these solutions are not idle. But we have developed a new feature that would solve the problem. It's called the remote dev. So let's see if my previous app has been deployed. I would give a try so let's see if it's been deployed. So you see, so I removed two uppercase, and it's now it's working. So it's been deployed. But what I'm going to do is run my application locally. So Maven Quarkus dev. Okay, it's on my computer, and there is. I would do like. So it's running locally. I would open a new terminal, and I will run the command Maven OC remote dev. And what it will do is actually creating a SSH tunnel. So it is like, so for instance, it will create the tunnels. So when you're working with your application, you have access to the remote services, and the services have access to your application. And it's like, it's actually, I don't know if some people know Star Trek. It's like you take your computer and you put it in the cloud. So it's exactly that. And if I go back to there, so it has created all the tunnels. I just had one command to run. And normally, if I run the application, I have to do a change. Sheep, and then done, and let's sheep. You can even also debug locally, but you are like in a cluster. So that's very cool. That was my light demo. I don't have time to make the waffle. I'm running out of time. But yeah, so if someone wants one IntelliJ license, come to me and I will make it. So it was not completely magic. I had to give some configuration file to tell which service to replace and which port to use locally in my machine. And that's it for my demo. Yes, that's it for my demo. If you want to go home with something, take a picture of that. You can replay the demos I've shown to you in this repo, and then and in this repo, this is the remote dev demo. Thank you.